It took just 121 seconds for history to change forever. More than 3 decades of nearly flawless safety were erased in an instant, when the supersonic Concorde struck a hotel just beyond Paris Charles de Gaulle Airport. But what exactly went wrong, and how did events unfold before that fateful takeoff? Based on the official investigation, let's go through the final chapter in the Concorde's story. Air France Flight 4590 was meant to be a relatively short transatlantic journey from Paris to New York SJFK Airport. On board were 100 passengers, most of them German tourists, along with 6 cabin crew members and 3 pilots. The passengers were scheduled to continue their dream trip by boarding a luxury cruise ship bound for South America, making this a once-in-a-lifetime holiday. The aircraft that day was none other than the legendary BAC Concorde. Introduced to the skies in March 1969, this masterpiece of engineering had been flying for over 30 years without a single fatal crash. Its distinctive delta wing design allowed it to perform across subsonic, transonic, and supersonic speeds, which made it unlike any other passenger plane. However, this wing design came with challenges. In order to generate enough lift during takeoff and landing, the aircraft needed to fly at higher speeds and angles of attack compared to conventional jets. For instance, while a Boeing 737 could lift off at around 140 to 150 knots, the Concorde typically required closer to 200 knots. This placed enormous stress on its landing gear and tires. Throughout its service life, the Concorde suffered 57 tire blowouts. In 12 of those cases, debris struck the underside of the aircraft, damaging its structure. On 6 occasions, pieces of tire even punctured the fuel tanks. One of the most serious prior incidents occurred in 1979, when a Concorde departing Washington, D.C., experienced a tire explosion during takeoff. Debris pierced a fuel tank and damaged the hydraulics, leaving the landing gear stuck in position. That event triggered a major safety review, which recommended stronger tires and better shielding of vital systems. Despite these warnings, the risks associated with Concorde's high-speed operations never completely disappeared, and on July 25, 2000, those risks would prove catastrophic. Investigators had previously considered the danger of fire from tire damage, but their conclusion was that only small amounts of fuel could leak in such events, and therefore the risk of a serious blaze was thought to be minimal. To understand what happened later, it's important to know a bit about the Concorde's fuel system. The aircraft carried 13 fuel tanks, 12 located in the wings and fuselage, and a 13th tank positioned at the rear. That rear tank acted as a trim tank, allowing the crew to move fuel forward or backward. 2. Balance the aircraft's center of gravity, which was especially critical during takeoff and climb. The Concorde was powered by 4 Rolls-Royce Snecma Olympus 593 turbojet engines, mounted under the delta wing near the rear landing gear. Each engine had variable intakes to handle airflow at supersonic speeds, as well as secondary intakes located below and behind the main inlets. These intake systems would later play a key role in the sequence of events. All 4 engines were also fitted with afterburners extra fuel injectors that provided up to 18% more thrust during takeoff. On July 25, 2000, preparations for Air France Flight 4590 began with complications. Another Concorde had originally been scheduled for the trip, but overnight the assignment was switched to this aircraft. When the dispatcher began preparing the flight paperwork, he discovered a technical issue. One of the thrust reversers was not working. While this didn't ground the jet, it carried a performance limitation that might require a fuel stop on the way to New York. Adding to the challenges, most passengers were German nationals who had flown in earlier that day. Due to a system error at Air France, several passengers and their luggage did not appear on the initial manifest. This meant the load sheet did not fully reflect who and what was actually on board. When the flight crew arrived, they were briefed about both the thrust reverser and the passenger list issue. They contacted Air France Engineering, who confirmed the thrust reverser could be fixed in time. Eventually, the passenger records were corrected, but even after adjustments, the plane departed carrying 19 more bags than were shown on the final load sheet, adding extra weight. At around 14 o'clock UTC, 16 o'clock local time in Paris, the crew began their pre-flight checks in the cockpit. The flight deck was staffed by 3 highly experienced aviators. The captain, age 54, with over 13,000 flight hours, 317 of them on Concorde, who would be the pilot flying. The first officer, age 50, with more than 10,000 hours total and nearly 2,700 hours on Concorde, who would monitor the flight. He also served as a Concorde simulator instructor. The flight engineer, age 58, who had logged over 12,000 hours, including nearly 1,000 on Concorde. This crew represented the elite and very small circle of Air France Concorde pilots, which numbered only about 30 in total. While preparations continued, the engineer confirmed that the thrust reverser had been restored to full working order. With that repair, the crew decided they could fuel the aircraft for a non-stop trip to New York. They settled on taking 95 tons of fuel. which brought the Concorde's departure weight close to its maximum certified limit. Performance calculations were then made. V1 decision speed, 150 knots VR rotation speed, 198 knots V2. Engine out climb speed, 220 knots. The dispatcher then returned with his own calculations, estimating a taxi fuel burn of about 2 tons. This figure would later prove to be inaccurate. By 14:25 UTC, preparations were complete. The cabin crew confirmed the cabin was secure, passengers were seated, and the flight deck received clearance to start engines. The crew lit them in sequence, engines 3, 2, 4, and finally 1. With the engines started, the crew requested clearance to taxi. On this day, departure was planned from runway 26 right, one of the longest runways at Charles de Gaulle Airport. The tower controller first asked if Concorde could depart from an intersection partway down the runway. But given the aircraft's heavy weight, the captain requested the full length instead. Clearance was granted, and at 14:35 UTC, the aircraft began rolling along taxiway Romeo toward the holding point. As they taxied, the crew continued their checks. The first officer noticed that the rudder's electrical control system kept switching from its main channel to the backup mode. He pointed this out to the flight engineer, who confirmed it was happening. After a brief discussion, they decided to continue using the primary system. Since the fault was classed as dispatchable, meaning it was not safety critical, they agreed it would not affect the flight, even if it occurred again during takeoff. Meanwhile, about 4 minutes before departure, the crew initiated a fuel transfer from Tank 11 at the rear of the jet to the feeder tanks. This shift brought the center of gravity to 54%, which was the optimal balance point for takeoff at maximum weight. The transfer completed just before departure. At almost the same moment, a Continental Airlines DC-210 lined up on the same runway and began its takeoff. During the roll, a strip of metal roughly 43 centimeters long detached from one of its engines. The DC-10 crew had no indication of this and continued their flight normally. With only 2 mandatory runway inspections per day in France at the time, the debris remained unnoticed on the runway surface. Unaware of this hazard, the Concorde drew closer to the threshold. The captain then gave a standard takeoff briefing, reviewing the plan with the crew. Departure, weight, 180 tons. Maximum thrust on all 4 engines with reheats engaged. From 0 to 100 knots, abort for any warning or tire failure indication. From 100 knots to V1, abort only for engine fire, a confirmed failure, or a sudden tire pressure, lost tire flash. After V1, they would be committed to flight, handle any issue in the air, and plan to return to land if necessary. This procedure was in line with Concorde's special requirements. Unlike most airliners, tire damage at high speed was considered critical for Concorde, so it was included as one of the few reasons to reject takeoff above 100 knots. After the briefing, the captain asked about taxi fuel usage. The dispatcher had estimated 2 tons, but the flight engineer reported only 800 kilograms had been burned. That meant the aircraft was still carrying nearly a ton more fuel than expected, pushing it about 800 kilograms above its maximum certified takeoff weight. The engineer also checked brake temperatures, which read 150 degrees Celsius, asked whether one side was hotter than the other. He replied they were even in observation that would later prove important to investigators. At 14:42 UTC, Concorde was cleared to line up and depart from runway 26 right. The tower reported surface winds from 090 degrees at 8 knots, giving the jet a tailwind greater than what had been used in their performance calculations. The crew advanced the throttles. Concorde was now seconds away from the flight that would change its history forever. Had the crew rechecked their performance figures after receiving the updated wind information, they would have seen that the maximum takeoff weight was reduced from just over 185 tons down to 180 tons. The limiting factor here was not thrust, but tire speed. With a tailwind, the aircraft needs to reach a higher ground speed before achieving the required airspeed for rotation. For Concorde, this meant the tires would spin faster than their safe limits. However, investigators later concluded that this particular factor did not directly contribute to the accident. And as any pilot knows, it is easy to overlook a last-minute wind change while lining up peacefully in a busy cockpit environment. Still, it serves as a reminder of how important it is to pause and factor in actual winds before beginning a takeoff roll. From this point forward, the next 121 seconds would decide the fate of the flight. At 14 hours, 42 minutes and 30 seconds, the captain pushed the thrust levers forward, bringing the four Olympus engines to full power with afterburners engaged. The aircraft began accelerating rapidly down runway 26, right? 24 seconds later, the first officer called out, 100. Immediately after, the flight engineer responded with 4 greens, confirming that all 4 engines and their afterburners were operating normally. Just 6 seconds later, the call of V1 was made. At this point, there was no turning back. The aircraft was committed to flight. This was about 35 seconds after the takeoff roll began. At 14 hours, 43 minutes and 9 seconds, the flight data recorder registered a slight yaw to the left. Notably, this movement was not caused by rudder input. Around this position on the runway, about 1,700 meters in, investigators later found broken fragments of the water deflector from the left main landing gear. This was the point where Concorde likely struck the metal strip that had fallen from the Continental DC to 10 just minutes earlier. Within half a second, a loud bang was captured on the cockpit voice recorder. The sound was consistent with the sudden explosion of a tire on the left main gear. Investigators confirmed this by finding both tire fragments and the metal debris in that section of the runway. 1 second later, at a speed of 178 knots and around 1,810 meters into the roll, another distinct sound was heard in the cockpit. The likely cause: pieces of the shredded tire were flung upward with such force that they struck the underside of the left wing near fuel tank number 5. The impact deformed the skin of the wing, pushing the metal inward. The violent shockwave created inside the tank, already full of fuel, had nowhere to dissipate, forcing a rupture outward. Fragments of this tank were later recovered on the runway, showing clear signs of an internal explosion rather than an external puncture. Fuel began gushing from the torn tank in large volumes. Almost immediately, a fire ignited. The exact ignition source became a major focus of the investigation. The most likely explanation was that the tire's violent burst also severed electrical wires in the left landing gear. The resulting sparks ignited the leaking fuel. Because the landing gear remained extended, the turbulent airflow behind the gear created a low-pressure zone that allowed the fire to remain stable instead of being blown out by the slipstream. The aircraft then began to drift left of the center. The captain applied right rudder to correct keeping the jet aligned, not due to engine issues, but simply to fight the imbalance created by the damaged landing gear and burning wing. The disaster was only just beginning. The sudden swing of the aircraft was most likely caused by the shredded tires on the left main gear, combined with the aerodynamic drag created by the fire trailing behind the jet. Just 2 seconds later, both engines on the left wing number 1 and number 2 began to lose thrust. Engine 1 was struggling because it had ingested large amounts of debris from the burst tires, including chunks of rubber and possibly hot gases. Engine 2, being closest to the damaged landing gear and fire, was overwhelmed almost entirely by the intake of burning gases. This disrupted the airflow inside the compressor, triggering stalls and choking the engine. Sensing the problem, the first officer urgently shouted, "Watch out!" And almost immediately the flight engineer echoed the same warning. Their concern was likely triggered by the extinguishing of the indicator lights showing normal operation for engines 1 and 2, confirming that both were failing to deliver proper thrust. At this stage, the aircraft had reached 187 knots still, about 8 knots short of the speed required for rotation. With engines 1 and 2 producing little to no thrust, the jet began yawing aggressively to the left. The captain fought against this with rudder inputs, but the Concorde was already drifting off the runway's centerline. It remains unclear why the captain chose to begin rotation at that moment. Perhaps he saw the runway quickly running out, or maybe he wanted to avoid other traffic visible ahead. What is certain is that he began to pull the nose up, but more slowly than usual, suggesting he knew the aircraft had not yet reached sufficient speed. During the climb-up, the flight engineer could be heard saying something that sounded like "stop," though the recording was unclear. A second later, however, he called out, "Engine failure, engine number 2. This was accurate. While engine 1 was starting to recover slightly from its stalls, engine 2 had dropped back to idle power. As the nose continued rising, the change in airflow around the wings caused even more hot gases to be sucked back into both engines. This triggered renewed compressor stalls, cutting their power nearly to idle once again. At that point, the first engine fire alarm blared inside the cockpit. The flight engineer immediately asked, "Shut down, engine 2. To which the captain responded, "Engine fire procedure." The engineer began the emergency drill, throttling engine 2 back to idle, pulling the fire handle, and discharging an extinguisher bottle. The alarm briefly silenced, likely due to the cooling effect of the extinguishing agent, but soon returned. The reason: the blaze was not confined to the engine, it was raging outside the wing. The heat was simply triggering the temperature sensors again. From the control tower, the air traffic controller radioed, "Air France 4590, you have flames behind you." The first officer acknowledged the message. Meanwhile, another pilot on the ground also reported over the frequency, "It's really burning, and it doesn't look like it's coming from the engine." This independent observation would later prove valuable for investigators. At last, the Concorde lifted off. But just before leaving the ground, its left main gear struck a row of runway-edged lights, scattering debris. Now airborne, the crew was confronted with a new and even more dangerous challenge: their dangerously low airspeed. Because the Concorde lifted off at a slightly lower speed than normal, it was now flying at around 200 knots short of the 220 knots required for a safe climb with one engine out. At this speed, the aircraft could neither climb efficiently nor sustain altitude. The first officer noticed this immediately and called out urgently, "Speed, speed," several times. Engine 1 was regaining some power, but the damage it had suffered meant it would never reach full thrust again. Engine 2 had already been shut down as part of the fire procedure carried out by the flight engineer. Engines 3 and 4 automatically entered contingency mode, generating maximum possible thrust to make up for the lost power on the left side. At this stage, the jet was only about 100 feet above the ground, climbing at roughly 750 feet per minute, still with a dangerously low airspeed. Air traffic control called in. Air France 4590. You have large flames trailing. You have priority to return to the airport. The first officer acknowledged. At the same time, the flight engineer reminded him to raise the landing gear. Initially, the first officer refused. Following procedure, if there was evidence of landing gear damage, the gear should not be retracted. But then the captain directly ordered retraction. The first officer tried, but the gear remained locked in place. The likely cause was damage from the tire burst earlier, which may have jammed the left gear door. Because the retraction sequence required all gear doors to move, the system prevented retraction entirely once one side failed. The captain checked with the flight engineer, engine to shut down, and received confirmation. Meanwhile, the first officer again shouted, "Airspeed, speed. The gear won't retract." At 14 hours, 43 minutes and 55 seconds, the flight data recorder registered the first signs of an uncommanded roll. This was most likely caused by the ongoing fire, which had by now weakened the inboard elevon on the left wing, disturbing the aircraft's control surfaces. The captain fought to counter the roll, but at the same time, the nose was pitching higher and higher, increasing the angle of attack dangerously. Listening to air traffic control, the first officer overheard the tower coordinating with firefighting units about a possible return landing. The crew then made a desperate call. "Le Bourget, we're trying for Le Bourget." The engine fire alarm blared again, and engine 1 surged once more, this time losing nearly all its remaining thrust. With almost no power on the left side, the aircraft rolled sharply left, reaching a bank angle of more than 110 degrees. The ground proximity warning system, GPWS, now sounded. Pull up, pull up. In a last attempt, thrust on engines 3 and 4 was reduced, likely an effort to stabilize the roll and bring the wings level again. But the effort came too late. At 14 hours, 44 minutes and 31 seconds, the Concorde struck a hotel in Goens, just west of Charles de Gaulle Airport. All 109 people on board were killed, along with 4 people on the ground. It was a devastating disaster, and investigators immediately began their work at the crash site. Among the wreckage, they recovered the left landing gear bogie and quickly noticed something critical. A spacer that should have held the wheels in precise alignment was missing. Without that part, the bogie could shift up to 3 degrees, introducing instability into the tires. This discovery raised 2 vital questions. Could the missing spacer have contributed to the accident? And was there anything the flight crew could have done differently to prevent the tragedy? I am always glad to have today's sponsor with us, because I know many of you enjoy exploring fascinating real-life stories and documentaries just as much as I do. That's exactly what CuriosityStream offers. It's a streaming platform dedicated to nonfiction content, with thousands of top-quality documentaries created by world-class filmmakers. Right now, I'm watching a series called Hurricane: The Anatomy, and it has really opened my eyes to how much I didn't know about these powerful storms. If that sparks your interest, you can visit CuriosityStream.com, Mentropilot. Use the code Mentropilot at checkout, and you'll get 25% off the yearly plan. That brings the cost down to just $14.99 a year, an amazing price for such a huge library of content. By signing up, you'll be supporting both me and the channel. Now, let's turn back to the Concorde investigation. When the inquiry began, one of the first questions was about a missing spacer in the landing gear assembly. Investigators initially thought it might still be at the crash site. Instead, they discovered it had been left behind at an Air France maintenance facility where the jet had recently been serviced. This was a major oversight, and the team needed to determine whether it had contributed to the accident. To answer that, they studied Concorde's performance data. If the landing gear had been misaligned during taxi or takeoff, it would have shown up in several ways: in even brake temperatures, abnormal acceleration, or rudder corrections during the takeoff roll. But the brake heat was balanced. The pilots made no unusual rudder inputs, and the aircraft's acceleration matched the expected performance. In short, the landing gear appeared properly aligned right up until the moment the aircraft struck debris on the runway and the tire burst. This meant that while the missing spacer was a serious maintenance failure, it had no direct effect on the crash itself. The spotlight then shifted to Continental Airlines. The metal strip that punctured the tire had come from one of their DC-10s. Maintenance records revealed it had been replaced twice in just 2 months. On closer inspection, investigators found it wasn't even built to the correct specifications. It had been drilled far more times than required, and its size was slightly off, causing repeated wear until it eventually detached. These findings triggered significant legal battles between French authorities and Continental. The crew's performance during the accident sequence was also carefully analyzed. The investigators concluded that the pilots were facing an unprecedented emergency. Both engines on one side lost, a massive fuel leak, and an uncontrolled fire. Passing V1 meant they were committed to takeoff. Aborting at that speed would almost certainly have caused a runway overrun, a gear collapse, and a likely fireball. Continuing into the air was the only viable choice. But once airborne, the aircraft simply didn't have enough thrust to accelerate or climb safely, especially with the landing gear stuck down. The extended gear may even have worsened the fire. Even if the pilots had managed to keep the jet level, the flames would eventually have destroyed controls and structure. Investigators concluded that there was virtually nothing the crew could have done to prevent the outcome. The official cause was traced to a tire rupture, something Concorde had experienced before, but never with such devastating consequences. As a result, the fleet's airworthiness certificate was suspended until safety upgrades could be made. These included Kevlar fuel tank liners to reduce rupture risk, upgraded wiring protection, and stronger Michelin tires designed to resist bursting. Concorde was grounded for over a year. By the time it returned, the aviation industry had been shaken by the events of September 11th. Passenger demand collapsed, and the economics of operating Concorde became unsustainable. The aircraft flew for just 2 more years before British Airways, the last operator, retired the fleet on October 24, 2003, closing the chapter on supersonic passenger travel.